Is AI about to become smarter than human intelligence, or is it mostly hype? Let's look at the actual progress. Welcome to The Explainer. Today we're tackling the ultimate big question in tech right now, AGI, or Artificial General Intelligence. We hear this term tossed around constantly, but to figure out if a machine will ever truly think like a human, we really need to pop the hood on the AI we actually have today.
So, are we actually on the brink of machines outsmarting us, or are we just getting a little too caught up in sci-fi movies? In this explainer, we're going to do a strict reality check. We're going to break down exactly how modern AI learns, the massive physical engines that power it, and, crucially, its stark limitations. That way you can judge the timeline to true AGI for yourself.
Section 1. The 4 types of AI and the AGI hype.
Okay, so researchers actually categorize artificial intelligence into 4 distinct stages. First up, you have reactive machines. These are completely task-specific with zero memory. Think of a basic chess-playing computer. Second is limited memory. This type learns from vast amounts of data over time. And honestly, that is exactly where we are today. But what about stages 3 and 4? Theory of mind, where a machine actually understands human emotion, and self-awareness, where it is fully conscious. Yeah, those simply do not exist yet. True AGI lives way down there at the bottom, and that firmly separates our current reality from all the hype.
Section 2. From Rules to Learning, the AI Evolution.
Now, getting to where we are today was anything but a straight line. It really started back in 1950 when Alan Turing famously asked, "Can machines think?" By 1956, the actual term artificial intelligence was officially coined at a Dartmouth workshop. But you know, that initial optimism, it definitely didn't last. The industry suffered these brutal funding cuts starting in 1974, which became known as the AI winters. The money just dried up because early systems couldn't handle the messy, unpredictable reality of the real world. Honestly, it seemed kind of hopeless until 2012, when absolutely everything changed, thanks to a massive breakthrough in deep learning.
See, for decades, engineers relied on something called symbolic AI. This meant humans had to manually hand code millions of rigid if-then rules. Like, if you wanted a spam filter, a programmer had to explicitly write out exactly what spam looked like. It was incredibly brittle. AI only truly exploded when we shifted over to connectionist AI. Instead of manually programming every little rule, we just started feeding the machine mountains of raw data and let it find the patterns entirely on its own. It's literally the difference between trying to mathematically explain to a computer what a cat looks like versus just showing it 10,000 pictures of cats and letting it figure it out.
Section 3. The Mechanics. How AI learns today.
So how does that learning actually happen? Modern AI basically uses a fundamental 4-step pipeline. It starts with the input phase, ingesting just massive data sets of text, images, or audio. Then comes processing, which is sorting all that raw data through complex layers of artificial neurons. Next, it generates an outcome, like successfully identifying a face in a photo. But the real magic, the absolute core of this whole thing, happens in step 4, adjustments. When the AI gets the outcome wrong, it has to learn from that mistake.
And that adjustment phase relies on a brilliant concept called backpropagation. Honestly, this is the secret sauce of modern AI. After the model produces an output, it meticulously measures exactly how far off it was from the correct answer. Then it works backward through its artificial neural network, slightly tweaking and adjusting the mathematical weights of its connections to reduce that error. No human is in there rewriting the code. The machine is essentially rewiring its own digital brain, millions or even billions of times, slowly inching its way toward total accuracy.
Let's ground that abstract math for a second. Imagine you're training an AI to recognize just the letter C. The network looks for a top curve, a left bent line, and a bottom curve. But early on in the training, it might see the top curve of a B and get totally confused. Well, through backpropagation, it realizes that error and literally adjusts its own internal mathematical weights. The next time, it won't be fooled. It repeats this process millions of times until it is perfectly accurate.
Section 4. Transformers and Generative AI. Now, the generative AI tools we all use today, they are just doing this exact same pattern matching, but on a mind-boggling scale. When you type into a large language model, it is really just doing one primary thing, predicting the next most likely word in a sequence. If your prompt is, "John gave a drink to," the model uses billions of calculations to figure out that, statistically speaking, Mary makes a lot more sense than apple. It creates this stunning illusion of deep human reasoning, but fundamentally is just highly advanced statistics playing a giant game of fill in the blank.
But you might be wondering, if it's just cold statistics, why does the AI sound so incredibly polite, helpful, and, well, human. That is all thanks to RLHF, which stands for Reinforcement Learning from Human Feedback. Human raters literally sit there and score the AI's outputs, rewarding it for sounding safe and natural, and heavily penalizing it for being rude or unhelpful. RLHF is basically the friendly mask slipped right over that complex math, making sure it acts like an eager assistant rather than just a robotic calculator.
Section 5. The Physical Engines. AI Hardware.
Of course, all of this software requires an unbelievable amount of physical horsepower. Standard computer processors simply cannot handle this kind of workload. The true heavy lifters of the AI revolution are GPUs, or graphics processing units, because they are absolutely perfect for training massive models in parallel, all at once. And for more specialized or dynamic tasks, engineers deploy custom-built chips like FPGAs and ASICs. These are hyper-efficient engines designed specifically for AI workloads.
What's really wild about this hardware revolution is the sheer cost of it all. Just one highly sought-after NVIDIA H100 GPU can cost anywhere from $27,000 to $40,000. And here's the kicker. Training a massive frontier AI model requires tens of thousands of these things, running nonstop for months. The road to AGI is quite literally paved with billions and billions of dollars of silicon.
Section 6. The roadblocks to AGI. But let's hit the brakes for a second. With all this data and wildly expensive hardware, why aren't we at true AGI yet? Well, we are hitting some stark reality checks. First is the black box problem. These models are now so complex that even their own creators don't know exactly how they are making decisions. Then you have hallucinations. Because the models are optimized just to sound plausible, they will confidently invent complete lies. Add in the issues of biased data and overfitting, where the AI just memorizes data instead of actually learning concepts, and you realize these are massive fundamental roadblocks on the path to true intelligence.
Section 7. Reality check. How close is AGI?
To be completely impartial here, some experts genuinely believe we are already standing on the doorstep. Back in April of 2023, Microsoft researchers published a fascinating paper arguing that models like GPT-4 are actually showing early, tantalizing hints of AGI. They suggest that when you push these pattern-matching engines to a massive enough scale, they begin spontaneously developing high-level, human-like reasoning.
Which leaves us with one final, incredibly provocative question. Can statistical pattern matching ever truly evolve into genuine human reasoning? Will simply piling on more data and tens of thousands of more chips eventually spark true consciousness? Or is today's AI just a brilliantly convincing mirage? It's the debate that is absolutely going to define our generation. Thanks for joining me on this explainer, and keep questioning the technology shaping our world.